In example 4, we have some fractions. So in order to solve an equation that has fractions, we need to eliminate the fractions. So I'm going to take each one of these denominators to help me determine what the lowest common denominator is. Starting with the number 4, I know that I can divide that by the prime number 2 and be left with 2. I can divide again by 2 and be left with 1. So all the prime numbers that 4 is divisible by are lined up very nicely here on the outside. So I have 2 times 2, which you could call 2 squared in exponent form. Next, we've got a 7. 7 is divided by 7, leaving me 1. So the only prime factor of 7 is 7. Finally, we have 14. Dividing 14 by a prime number, I could start with 2. 14 divided by 2 leaves me 7. 7 divided by 7 leaves me 1. So 2 times 7 are the factors of 14, the prime factors. So to build my lowest common denominator, that is the product of each unique factor to its highest power. So what I have to choose from is 2 squared, 7, and 2 times 7. So it looks like I have 2's and I have 7's. So I have 2's and 7's. Now I want to go back and make sure I have the highest power accounted for. For our first denominator of 4, I had 2 squared. That is a higher power than 2 to the first. So I need to account for the higher power. Next, I've got 7. So I've got 7 to the power of 1 and 7 to the power of 1. Both of those are 7 to the power of 1. Don't combine them. They are from different denominators. So the best we can do is have 7 power of 1. So however much 2 squared times 7 is, that's our lowest common denominator. So that would be 4 times 7 or 28. So the way we're going to use 28 is multiply every term by 28. So I'm going to have 28 times n minus 3 over 4 plus 28 times n plus 5 over 7 equal to 28 times our last fraction, 5 over 14. So what's going to happen here? 28 is not just floating anywhere. 28 is an integer. It's 28 over 1. So maybe that will help us to do some tracking better. So 28 can reduce with 4 in that first fraction. 28 fourths is exactly 7. Our next fraction, 28 reduces with 7, gives us exactly 4. And 28 reduces with 14 and gives us 2. So we don't have fractions anymore. That's why it's so nice to figure out the lowest common denominator and then multiply all the terms, because then the fraction will be eliminated. So I'm actually distributing 7 now to each of the terms in this first parenthesis set. 7n minus 21 is what I get. Next, I've got positive 4 to distribute into the second parenthesis. So positive 4n and positive 20. Last, positive 2 is multiplied by 5 to give us 10. So now it's more clear to see that we do not have any fractions remaining. But we do have a lot of terms here, so we need to collect our like terms. 7n and 4n are like terms. And then we have negative 21 and 20 our like terms. So 7 plus 4 would give us 11n. Negative 21 and positive 20 would give us minus 1. And that is all equal to 10. Notice that we only have one term that's a variable, so we're going to leave 11n right where it is, and we'll move this negative 1 by adding 1 to each side of our equation. That's our addition property of equality. So we eliminate it from one side and collect it on the other. We're left with 11n equals 11. And our final step, to get n isolated, notice n is being multiplied by 11, so the opposite would be divided by 11. Both sides of the equation are divided by 11. So now n equals 1. We actually have a solution, and when you do have a solution, it is called conditional. There is a solution, and that condition is that we let n equal 1, and that will solve the equation. So we've got one more example to work. In our last example, we have fractions again, but it looks a little bit different. So in order to know which terms really have fractions, I always suggest that you distribute before you try to eliminate the fractions, that you don't end up multiplying too many times by the LCD. So by distributing first, we'd have 1/3 multiplied by 8. So that's 8/3. 1/3 times 2c would be positive 2c over 3. So you can see how both of those terms actually have a denominator of 3. Now distributing 1/5, we would have 3c over 5, and 1/5 times negative 5 would be minus 5/5. I don't want to reduce 5/5 right now. I'm distributing on purpose so I can see what the terms look like as fractions to come up with our lowest common denominator. So one denominator is 3, the other denominators are 5, and if I try to divide these, well, they're only divisible by themselves. So they already are prime numbers, and they're different from each other. So 3 times 5 means 15 is our lowest common denominator. So I'm going to take 15 and multiply that by each term in our equation. So notice that 15 really could be written as 15 over 1, and it's fine to write that out if it helps you to track this better. And so we really can do some reducing here to eliminate our fractions. 15/3 really is 5. 15/3 again is 5. 15/5 is 3. And again, 15/5. It is really negative 15/5, which gives us negative 3. So you might find it helpful to include the negative with the 3 so you don't forget to use the negative, and that is a very common mistake. So what we have remaining is 5 times 8, which is 40. Positive 5 times 2c is positive 10c on the left. On the right, 3 times 3c would be 9c, and negative 3 times 15 gives us negative 15. So again, we're back to collecting variables on one side and constants on the other. So I'll subtract 9c from each side, and that leaves me 40 plus c equals negative 15, and subtraction of 40 will finish our problem. So I'm left with c equals Now the sum of two negative numbers is going to be a negative 55. So our answer C equals negative 55. Since we do have an answer, it's conditional.